Well then, what do you think about that? Berserk. Plasma filaments. Ejecting and reorienting. Also coronal mass ejections, new sunspots, and lots more to cover on today's edition of the Daily Space Weather Show. And thanks for tuning into the Smash News Network, least busted name in news. That's a 24-hour video on ionized helium from the Solar Dynamics Observatory. And we've been naming filaments for the reason that they are lively. They have a tendency to have behaviors that are well documentable. Here's a slightly zoomed out 24-hour video. That is 30 frames per second, and it depicts 24 hours. The solar southern hemisphere. By the way, if you want to name filaments, go follow us over on X. Yeah, on X. Just follow the hashtag #NameThatFilament. So you will see a CME coming out of the west there. We'll talk about whether that's earthly directed later in the video. So we've got lots to show today. It's another exciting day for space weather, and despite a dip in solar activity here, yesterday's video title started with the words filaments, filaments, filaments. Is it starting to make sense? Are you getting why we decided to name the video that? Let us know in the comments what you think. And just a brief overview here of our paid affiliates. One of those is our Hemp Lucid shop. You can find links below the video to that if you're in the market or considering trying the mushroom gummies or perhaps the mushroom stacks. What about the CBD tinctures or various different types of capsules like the full spectrum CBD capsules? What about the body balms? The cedar wood smells fantastic. Even CBD for your pets available there. Links below the video and on the homepage. You can also find the Amazon shop. It is amazon.com/shop/smashomash. We just added some products there in the cycling items. Yes. You know, because a lot of times when we reach our peak form in the sport of cycling, we find that, well, we can go pretty fast, but we're just nothing more than a walking injury. So check out some of those products over there. Amazon.com/shop/smashomash. You can also find links on our homepage. And welcome to the Neo Renaissance. Thanks for tuning into the channel. This channel is the most comprehensive daily space weather in the known universe, also the most detailed imagery of the sun you'll find anywhere. And if you weren't aware, we typically stream the GOES 16 SUVI all day long on the Twitch channel. And there's what was going on. That was like 2:30 this morning. The GOES 16 does have a wider field of view, so it does show that filament to a greater degree of distance as it ejects the corona. Some of it splashed back down. And the filament that we actually named, this one here, kind of just stayed there. So that's the scenario going on. Let's take a look at sunspots. So we've got two more groups that'll get names today, likely. This one right here just formed, right there, and this one down here. So I believe there are three, maybe even three new sunspot groups there that aren't named yet in the southeastern limb. Here's a colorized magnetogram. This SDO browse data imagery is yesterday plus today, so August 9th and August 10th to date. Interestingly enough, we don't have any sunspots up here, even though this is actually the brightest portion of the eastern solar limb. Let's see what's going on planet Earth. Always interested in that. What about you? Maybe not. Maybe you're looking to the skies because you're sick of what's going on planet Earth. Anyway, Here is our list. Starting out with Mayan, producing an unknown volcanic ash plume. Don't pole vault the caldera. It could be unhealthful. Bagana, showing a thermal anomaly in volcanic ash emissions to 8,000 feet of altitude. It's a flight level 080. Ulawun, on New Britain, Papua New Guinea. Seismic activity continues to fluctuate there. And white plumes drifted 11 to 12 kilometers northwest of the volcano. So gas and steam emissions rose at Ulawun. Semeru also exploding, flight level 140. It's a 14,000-foot ash plume, 23,000-foot ash plume over Colombia at Nevado de Ruiz. Two usual suspects in Ecuador, Sangay and Revenador. Sangay producing a 21,000-foot ash plume, Revenador producing a flight level 130, a 13,000-foot ash plume. 23,000-foot ash plume over Peru from Sabancaya as it explodes. It's a flight level 230, flight level 220 over Ubidas in that same nation. And Piton de la Fournaise has lowered its volcanic alert level. The eruption has apparently ceased there on Piton de la Fournaise on the Isle of Réunion. Slight advance of lava flows there. Seismic activity had remained low in general. And let's look at seismicity briefly. We'll cover the largest quakes of the past 24 hours. There is the past 90 days. Very perfectly spaced out 7 magnitude earthquakes there over the past 90 days. Very uniform eruption of 7 magnitude quakes. Swarm of small quakes continues in the Caribbean, and there was a 4.0 off the coast of Oregon there at the Cascadian Fault Zone. We'll only talk about quakes of a 5 or greater magnitude, though. And there weren't many. It's been quite seismically calm. The list starts out with a 5.2 at Indonesia. That was at 2 o'clock Universal Time this morning. It was at a depth of 90 kilometers. Also a 5.1 there, very nearby, also at Indonesia. And those are the only 2 5+ magnitude quakes occurring in the past 24 hours. And let's go back to space. Here's some more space right in your face. Another 24-hour video from SDO, 171 angstroms. Again, you might notice this bright, active region up here. No sunspots when we did show prep, but a few down here. I think there are 4 sunspot groups down here in the southeast. A prime example of how the brightest portion of the lower corona, which is what's depicted by 171 angstroms, may not be the area with the sunspots. It's just one of those things. So there is the eastern limb. So there's a new group that just formed right here. This one's already got a name, and then there are 2 more to its southeast. That's what's going on the eastern limb. Brief look at the western limb. And the largest flare-producing region actually produced 2 C-class flares. That was this southwestern group. And I should be off-screen. There we go. That's better. And we'll zoom back out here and add 211 angstroms to show the lower and the extended corona. That's a pretty good composite, wouldn't you say? All right, let's, by the way, that is another, these are all 24-hour videos. Typically, that is what our Helio Viewer movies are. And let's talk about some solar stats. The 10.7 centimeter radio flux is all the way down to 153 solar flux units. And there is the 1-year graph of the radio flux depicted by this black line. 153 is the new radio flux number. Seeing a continued decline here in solar activity, getting below this 155 support level that we've talked about many times on the channel. Right in there. Lots of upward resistance at around 155 solar flux units. And let's move on to the Space Weather Enthusiast dashboard. No geomagnetic storms in the forecast here. not by NOAA at least, and no new modeling by NASA either. So again, we'll talk about coronal mass ejections a little bit later in the video. This is the past 4 hours of Earth's magnetic moment from space. It depicts magnetohydrodynamic pressure, and it is a low pressure environment based on the variables that are input on the space weather modeling framework. If you want to read about that, click the Details tab on the Geospace Magnetosphere Movies page, and you can even download the software used to generate these images. Another model is the Ground Magnetic Perturbations Map depicting changes to Earth's B field, Geospace Delta B. This depicts nanotesla, which is magnetic flux density from the surface level, the last 4 hours of Earth's magnetic moment from the ground. And it is geomagnetically calm. Planetary K index, otherwise known sometimes as the KP index, is currently 1.6. When we say 1.6, that's because that means it's a repeating decimal. When you notate a repeating decimal in math, you put a bar over that number, indicating that it repeats. 1.6666666 ad infinitum, rounded to 1.67. Very geomagnetically calm at the moment. Solar wind conditions are quite diffuse solar wind there at only 1.95 protons per cubic centimeter. Solar wind speed here, so density just around 2 protons per cubic centimeter. Solar wind speed here around 370 kilometers per second. Those are pretty unremarkable data as well. GOES magnetometers here showing one little higher reading here. It looks like the scale has expanded a little bit, reaching all the way up into the mid-130s there for the GOES 16 and GOES 18. That is not really anything exciting. And next, let's look at the top view ecliptic plane field plot. It is one of the best sets of data that we could possibly look at here. And Earth is remaining in a South Pole current sheet for the foreseeable future here. So now we could see a North Pole current sheet pop back up, especially if those sunspots in the southeastern limb decide to grow. But at the moment, as you can see here, Earth is in a South Pole current sheet close to the middle of it. North Pole current sheet is way over here at the moment, and here is our top view. Here is our line of sight field plot. That was the top view ecliptic plane. Here's a line of sight field plot which depicts the solar B field in blue, north and south polar fields in green and red respectively. And the grayscale depicts the gong magnetogram, which brings us to coronal holes. And don't expect the shortage of coronal holes to continue. We've seen a huge shortage of coronal holes really for this whole solar cycle, folks. And coronal holes are a super important feature of solar cycle progression. They show us the solar polar field reversal process. So let's bring up the latest image before we show some more HelioViewer movies. So we've got mainly South Pole oriented coronal holes here. And there's the past 24 hours in SDO 211 angstroms. So this has actually been the most well-defined one for quite a while, and it is of South Pole orientation. Continuing right along to go to sunspots. So here's the sunspot situation, and not so many sunspots here at the moment. Again, a big decline in solar activity in the past week. So let's see, we've got 3399 is named. This will be 3340 And then we've got 3341 and 3342 potentially down here in the northeastern limb. Here's a 24-hour video from SDO Continuum. So 4 sunspot groups appear to be forming here in the southeast. So there's one here, one there, and then there are 2 more down here, at least when we did show prep. These active regions up here are not displaying any sunspots, at least not yet. And it's time for energetic particles and solar flares. Ghost proton flux here is subsiding. So we are seeing a subsiding of the southern polar radial blackouts. That solar energetic particle event was associated with an X-class solar flare occurring on August 7th. And that was a pretty significant SEP, solar energetic particle event. And here, if you look at the deabsorption regions prediction, look at the south polar radial blackouts there. Those are expected to be subsiding. The north polar ones will follow. So in the next 24 hours, those north pole radial blackouts might be completely gone. There is the X-ray output. We've seen a dip in the X-ray output. No real surprise there, following a huge peak around August 7th, especially. Since then, things have been a lot calmer in terms of solar X-rays, pushing back down toward a B-class X-ray output. You might be wondering if that affects my forecast for solar cycle 25, and the answer is not really. Not at all, in fact. Here's 94 plus 131 angstroms. Again, the largest flares came from, they're just C-class intensifications from this southwestern group. And with the growth of those new sunspots in the southeastern group, southeastern limb, those sunspots might produce some flares. We'll show a magnetic analysis of those a little bit later. There's an equatorial zoom in. Another 24-hour video at 30 frames per second. 94 plus 131 angstroms. 2 of the many species of ionized iron and their extreme ultraviolet emissions from the Solar Dynamics Observatory. It's a good time. And it's going to be a good weekend to look up, especially if you've got clear skies and low light pollution. Now, this is what's going on overhead at Lehigh Valley, Pennsylvania. That's where we're located. Smash, staff, and I. It's a 2-person operation. And it's going to be a weekend where you may want to go out and look in this direction, into the constellation Perseus. Why? We'll get to it in a moment. First, a solar system forecast. So this is where things are today. Ta-da! Let's advance this 1 week. Here's where things will be in a week. Around new moon for August, around the 16th and 17th. So, why Perseus? Because of Perseids, of course. So the radiant here is kind of at the border between the constellation Perseus and Cassiopeia. And the handle of the Big Dipper kind of points toward Perseus, if you're familiar with that. And there's a great image of some Perseids. That is from back in 2016, I think. Not sure what year that is, but there's an article on SciTech Daily. You'll find articles all over the internet about Perseids. So Friday and Saturday nights will be great nights to check them out. And you can see that article on SciTech Daily. talking about when to view it, and basically it means it's all night. So, and that is a result of cometary dust. From the Swift-Tuttle comet. Today's astronomy photo of the day is up from Mars. That drone here, it's hovering about 16 feet over the Jezero crater. And there is the rover up there. apod.nasa.gov. That's the 54th flight from the Mars helicopter there. apod.nasa.gov. Next we'll move on to CMEs. Yeah, CMEs. Coronal mass ejections. When material, mainly protons, which consist mainly of hydrogen nuclei, are ejected from the sun's atmosphere, as magnetic fields disobey gravity, sending material blasting off into space. You may be wondering if that's an earthly directed coronal mass ejection, and the answer is, we don't think so. So that's 98 frames from yesterday, August 9th. Here are the available frames from today, an additional 26. And a CME popping off there early this morning in the southwestern region. So let's look at, there's Soho Lasco C2 NC3. And that might look a lot like a halo eruption. But we don't anticipate that to be earthly directed because it is on the far side. So here we're showing stereo A as well. And by the way, we show this. Feel free to pause this image. It shows you the location of Bepi Colombo and the Solar Orbiter spacecraft. Also the Parker Solar Probe, which is the orange. Stereo A depicted in red and stereo B depicted in blue. Stereo A is almost right between the Earth and Sun here at the moment. And it's showing some anomalies here going on for days. Not sure what's up with that. Let's briefly show this halo eruption. So typically when we see a coronal mass ejection where you see ejecta on all sides of the coronagraph, it means one of two things. The CME is earthly directed or exactly opposite, directed away from Earth. And that's what we anticipate this one to be. Based on the coronagraph data that we see, that is a far side coronal mass ejection, not the kind expected to strike Earth. So here are our custom coronagraph movies. And as we zoom in closer, you'll probably agree that that is not an earthly directed CME despite the halo. That's once again 24 hours at 30 frames per second. Still lots of snow on the coronagraph there, indicating relativistic particles are still striking the aperture. They're just not really increasing the proton flux here at planet Earth. So if we move in one more level here, you'll be able to see some, right here you can see some activity popping off there, and it does not translate to this side of the solar disk. So we don't see any limb darkening or any plasma reorientation happening around this area where that CME looks like it came from, indicating that it is on the far side of the sun, not earthly directed. Which brings us to filaments. 193 angstroms shows filaments pretty well. Let's take a look at them from the ground-based observatory at El Teide, Spain. So El Teide, Spain, we're looking at hydrogen alpha here, 65, 62.8 angstroms. The Donna Marie filament remains intact. The Kate Bush filament remains intact. Also, the Mike Smith filament remains intact. And the Meghan Markle filament is still hanging out down here near the polar region. And we'll also show this in color. Just keep in mind that all of these prominences are not going to show up in the color imagery. It is also from El Teide, Spain. And there is the color imagery. And what's next, you ask? So do I. By the way, if you want to name filaments, join us over on X, the platform formerly known as Twitter. If you've unplugged entirely from social media, then, geez, I'm not following Mike. Hey, Mike, there we go. Now we're following you over on X. And before we get the bonus features, here are the past couple of hours from the GOES 16 SUVi. So yeah, Meghan Markle filament, Donna Marie filament, Kate Bush filament right here, and the Mike Smith filament are the main Earth-facing solar disk filaments. Any of those could become a coronal mass ejection. And remember, folks, you don't need to see a solar flare or even a sunspot to see a coronal mass ejection. They happen on the regs without any kind of activity. Sometimes they just spontaneously blast off, because magnetic fields collapse and plasma reorients, and off they go. So here come bonus features. Satellite charging hazards are first, and we don't have any. It's smooth sailing, no surface or internal charging hazards for satellites. The GOES electron flux here in a fairly moderate range. We did reach into warning levels a little bit yesterday, approaching them once again today here, as the GOES 16 and GOES 18 are climbing in their radiographic measurements of electron flux. Keep in mind they're at a geosynchronous orbit at like 23,000 miles. They're measuring the electron flux at about 300 kilometers. So way down is where they're measuring that electron flux using radiography. There's the 1-year graph to put it in context. And I suspect that the electron flux is going to rise a little bit higher yet today. So here is the NOAA forecast model. I suspect the next update will actually be maybe up here. The green boxes are NOAA's forecast. The yellow diamonds are the observation. We also like to show the F layer of the ionosphere, which is where that is measured. Feel free to pause the video in this frame if you're not familiar with the temperatures of the atmosphere, the electromagnetic radiation penetration into different layers, and chemical concentrations. Here is the vibrational frequency of the F layer. That's, again, about 300 kilometers of altitude. We don't expect to see well, there certainly are some low-frequency anomalies happening there. And don't worry if you're not familiar with looking at this. If this is Greek to you, it's depicting the vibrational frequency of that diffuse bridge between Earth and space, the F layer of the ionosphere. That is courtesy of Australian Government Bureau Meteorology, by the way. And let's show the anomalygram. Certainly quite a few low-frequency anomalies happening here depicted in red. This is anomaly in megahertz from the 30-day median. So that is what's going on real high in the sky. Here's the latest image, 11:45 universal time for the ionogram, and there is 11:45 universal time for the anomalygram. We also show total electron content. That is free electrons between your GPS satellite and your handset, a run of about 12,500 miles. And a lot of free electrons will cause the signal to refract. Here's the total electron content forecast. So things are looking fairly orderly here. No major anomalies happening in the total electron content. By the way, if your GPS is expected to produce errors, try Wi-Fi location accuracy when the known ground points of IP addresses can help you navigate. Here is the total electron content anomaly from the 10-day average. And no major anomalies there for North America. We'll close out the space weather portion of the video with the latest intensitygram and the latest colorized magnetogram. Do we have any sunspots up here in the northeast yet? I don't see any. I don't think so. However, in the southeast, it's a different story. So there's a new one that's just formed. This is the most promising sunspot for continued growth as it's growing kind of rapidly. This is 3399. And then this is a new group right here, also beta gamma class, and this group down here is a new group. So that is what's going on. Let's show the magnetic fields. Let me see. I'll get right in the middle here. There we go. So that's beta gamma class, that's beta gamma class, that's beta gamma class, and they're all beta gamma class. There you go. And let's show the full disk view. Whoops, there we go. That was your teaser for the meteorology segment, which is what comes next here at the Smash News Network, least busted name in news. And we're starting out the meteorology segment with sea surface temperature anomalies. If you want to know about anomalously warm and anomalously cool water, well, this is the place to do it. So there is the Arctic. It also depicts ocean currents there. That's the animation. The color gradation is sea surface temperature anomaly. Here is the Atlantic. A lot of hot water in the North Atlantic. A lot of hot air on YouTube about climate and about space weather. The Indian Ocean is depicted here. How about the Southern Ocean? And last but not least, Earth's largest surface heat sink. There is a lot of heat stored and indeed dissipated by the Pacific Ocean. And there it is. And let's move on to regular meteorology. We offer value-added services. So there is the surface wind scenario for the eastern world. Here are the jet streams. Jet streams for the western world. Let me move that a little bit. There we go. A doubled up jet stream over the eastern portion of the U.S. there. A separate jet stream for the Great Lakes versus the Mid-Atlantic states. Here are the jet streams of the central world. Major meridional jet stream flow here around northeastern Europe, northern Europe, etc. And here are the surface winds for this side of the planet. Next, looking at plain old sea surface temperature anomalies. So this is, I'm sorry, not anomalies, that's just sea surface temperatures. And a huge temperature gradient happening right here. Temperatures going from 60 degrees to nearly 80 degrees. A pretty small area there. And it probably looks less anomalously warm and cold in various places there. That's one of the many features of windy. Here's the clouds and fog scenario for the Americas as we zoom in closer to the lower 48. We zoom out from space weather and into American plain old weather. It's clouds and fog, shortwave radiation. Here's your smoke map. It looks like there is some thick smoke headed toward Maine. Maine is going to get hit, following a bunch of flooding The rest of the country, for the most part, they're pretty chill as far as smoke forecast. That's firesmoke.ca. Here's your weather.gov map. We do have some severe weather warnings there, it looks like. Some flash flood warnings, some heat advisories, and so forth. Things are calming down at Hawaii. And it looks like some fog in Illinois and Missouri. Here comes some forecasts for you. This is the GFS 72-hour temperature anomaly forecast in degrees Celsius. Here is your jet stream forecast. 250 millibar winds based on the same GFS 72-hour model. And there is pressure and precipitation. Once again, the GFS 72-hour pressure and precipitation forecast. So it looks like we may have clear skies on Saturday night there. May have to have a Perseid party. Next, we'll show the lightning mapper. There's the past about 10 hours. Some quite heavy thunder there. Thunder and lightning across most of Tennessee, southern Kentucky, and the southeast in general. That's the lightning capital of the U.S. for the past about 10 hours. And let's check out a current lightning map. Do we have any thunder rolling in at the moment? Hey, Charlotte. Hey, Spartanburg. It looks like you are in the crosshairs. Also, Charlotte. Those are some fairly mild-looking cells. There's your full map. Next time you hear thunder, check out lightningmaps.org. Convince the natives that you're Zeus or Thor or something. By the way, if you enjoy the content, consider becoming a member of the Smash Team. We send out email alerts for videos just like this one, as people have complained many times that they're not getting notifications for videos hosted. Well, that's no surprise to us. That's why we created email alerts. We even send those out to bronze level Smash Team members. We even sent out an alert about that CME propagating last night. And of course, you can find the Twitch channel there on the homepage at smashomash.com/SmashTeam. Links to that below this video. There is a bronze, a silver, and a gold annual paid up subscription level. Get additional content that way. Today's featured product is now our second best seller, which is Universum Liberate, the Galactic Federation Special Forces. So check that design out. I'm actually wearing it today. Whoops. Here I am. Universum Liberate. If you're sick of what's going on in your local town or county or your state, your regional area, what about your country, continent, hemisphere, planet, or solar system? Branch out. Support the Galactic Federation Special Forces. Convince your friends and foes and neutrals that you're in the Illuminati by saying Universum Liberate. If that's too reckless for you, let me just say this. If I could wave my magic wand, I'd set everybody free. Again, maybe that's a little too reckless, but there are reasons for freedom and liberty to be a thing that people still prefer. If you're wondering what the symbolism means, the key represents signal strength and integrity. The lightning bolt represents galactic scale reach. This little bright spot up here represents classified, and the spiral represents the Milky Way galaxy. Universum Liberate, the motto of the Galactic Federation Special Forces. If you're looking for our merch, you can find it below the video, as well as on the homepage at smashomash.com. Again, welcome to the DR Renaissance. Congratulations on realizing the channel exists. We're going to close this video out with U.S. Doppler radar. We'll show the full 50-state view briefly. And then continue with the lower 48 view. So Atlanta's going to have several hours of rain here. And Charlotte will be getting hit when this video premieres. Here is the shortwave radiation map depicting clouds and fog. And it looks like some activity forming down here, some rapid cloud nucleation happening there. North of the Caribbean, north of the Isle of Dominica, featuring Haiti and the Dominican Republic. These systems are moving almost due east. And just a quick reminder, if your Doppler is not being clear, check out the water vapor map, which is what we're showing here. It will clarify things, especially if you understand atmospheric physics, which will also allow you to forecast your weather. Anyway, here's your recap. U.S. Doppler radar is a ground-based system which depicts vertical motion in the air column. Shortwave radiation is a space-based system which depicts 3.9 micrometer infrared radiation, which shows clouds and fog at nighttime. And 6.19 micrometer infrared radiation, the satellite-based water vapor map, depicts water vapor, as in all of it. And it's probably clear skies over Missouri at the moment. And we hope it's clear skies for you this weekend. If you're going out to view the Perseids, if you take some especially time-lapse footage, share it with us on social media, etc. Once again, thanks for tuning into the Smash News Network, least busted name in news. I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.